on this computer. Okay. Okay, right. Okay. Thank you so much. Okay, let's start the class. Okay. So my name is Dr. Siddiqa Mazhar. I am your instructor for this course of probability and statistics. Welcome to the summer semester. So first, let's start from introduction. What is your name?
My name is Nick Henderson.
Sorry, say that again.
Nick Henderson.
Nick Henderson. Okay. So the rest of the students are not present. I was asking. So let's go start from the syllabus. Okay. Let me share the screen first. There is you would see the same Moodle as I can see when you go over the Moodle. Where is my Moodle? I will close it. Anyways, I can't because this is I can't see due to this reason. Okay. Okay, let's start from the syllabus. Unfortunately, I'm not able to open directly my Moodle shell because this is also my first class over here in Midmish. So let's start from the syllabus that is available on my Moodle shell. Hopefully, you can also see on the Moodle shell. So this is the course of Introduction and Probability. Introduction to Probability and Statistics. Let me go to the presentation. Okay. And this is summer semester 2021. And it will be always held on Monday and Wednesday from 9 to 10:45. My name is Siddiqa Mazhar, and the contact information I am having, few things are not available, like I need to write down the Zoom meetings for you for my office hours when I would be available, or you can also come to meet me in person. I will update my location in this campus. If you want to meet me in person, you can schedule the meeting by email to me, or I will write the office hours for me as well. So here's the course description. We will be covering everything, most of the topics in probability and statistics that is available in the book that I have been mentioned over there. So the prerequisite for this course is Calculus 2, I think Math 2 104, and the C grade is required for that. If you have anything, complications, like you feel any kind of difficulty for this course, you can come to me and you can ask me, you can email me. And the materials for this course is this textbook is available freely online. You can also see it on my Moodle shell. I have linked it. I have a link attached to my Moodle where you can see this book, Introductory Statistics, and it is freely available. And for this course, you need a calculator, which is TI-84. Hopefully it will be freely, not freely available, but in most of the stores, it's available over there. You can find it out either on Amazon or you can figure it out. But if you have TI-83, that would also work the same. It would also work for this course. The other things you are required is only pen and paper to write down the notes for you, and the other lecture notes and any other notes or practice tests, it will be available on the Moodle shell for you. The attendance policy, as far as the attendance policy is concerned, I will upload the quiz or homework assignments at the end of in each week. The only thing is that I want to make sure that you are learning in this class and you are attending all the lectures. So I want you to cover up all the things. And if you just have to, on every Monday morning, I will upload all the homeworks and you have to done it by each Friday. So it is, this is your responsibility to complete it or finish it on time. And you don't wait for the last moment. For instance, some students said that, okay, on Thursday, it has happened to me, something happened to me, I had this problem and I couldn't get time for Friday. Don't wait for the last moment. So it's better to do things earlier than later. So as far as grading policy or is concerned, there will be 2 exams that has worth 100 marks of each, and there will be one comprehensive final exams of 150 points. And the rest will be 10 homework assignments will be for you, and each assignment has 10 points that will be held in the end of each chapter. I would upload a quiz or homework assignments for you in each week that you have to complete it by Friday, 5 p.m. Okay. So as far as grading policy is concerned, the total marks you will be having 450. Whatever the marks you will be earning, you will get the percentage of it. And if it is like something you get like 80.5 marks, then it will be round off to the next number, that is 81. And if you have less than 0.5, like you say, let's say 80.4, then it will be round off to 79%. So it will go according to the percentage, and the letters grades has been mentioned in this chart. 1 second. The exam procedures, all the exams or the homework assignments will be held on the Moodles, and there will be logged on browser will be available for you. There will be a setup time. You have to fill it on time, the exams. And the other things, well, there most of the things I will update you time to time. If there will be any changes in the exam procedures, I will let you know beforehand. But hopefully everything will be done on the Moodle shell. So homework, these are the homework procedures that I told you that every Monday morning I will upload, and by the end of Friday, 5 p.m., you have to make sure that you have completed all the assignments. And late assignments will not be accepted. And unless there is very, emergency or any kind of, you need to let me know that what kind of urgency you can have. But lame excuses will not be acceptable, right? So, and extra credits, there will be no extra credit for this course, but if anything happens for the grading policy or whatever, the things ups and downs will be there, then it can, if there is, but I don't think that there are any kind of extra projects in this summer course, because this is very short term. So if any kind of projects or extra problems are concerned, then it will be held by the end of the semester or in the last week. Go so early or not? Okay, group work policies for as far as homeworks are concerned or assignments are concerned, you can work in a group. I have no issues that if you work in groups or you ask your friends and you work together. I don't have any problem for as far as homeworks are concerned, but the test and the quizzes, that has to be individual and will be using by the lockdown browser. So any kind of academic dishonesty like plagiarism or anything can happen, it can automatically be detected by the Moodle, or there will be the policies, and that I will come to know that if there is any dishonesty, and you will get no marks for that, and I have to contact it, or I have to inform it to the college if anything of any kind of this case can happen. It would happen then. So this is a HyFlex course. As you know that some students you are face-to-face, some students will be online. So most of the assignments and quizzes or homeworks, this will be done on Moodle, and I would ask you to upload everything on Moodle as well. So cell phones and are not acceptable, but you can use calculators, as I told you, TI-84 calculator you can use. So the rest of the things, I think I have mentioned everything over there. As far as office hours is concerned, I have to update it soon on it, because so far, even I don't know what is my location of the office in this building. So I need to know, first of all. As soon as I come to know, I will let you know. And my office hours will also be available soon by the end of this week. In case of any shutdown happen, or like sometimes, let's say, I heard that there was a snowstorm previous year, then the office, everything was shut down. So I will let you know, or I will announce everything on Moodle for you. So these are the college policies. The ADA policies have been mentioned on this link. And the general education program, this has been available on this course outline. And as far as college mask policy is concerned, so far we are using all the precautionary measures for COVID-19. But as far as the things will get better, I will let you know that when the mask is not mandatory, or you can come without mask or something like this. So all the information will be available on it, or I can announce it on the Moodle shell for you. And the Clery Act, if there is any crime happen to this college, this is available on this link. You can go over there and you can check it. For FEPRA information, you can also click on it and you can get the information on the following link. And that's it. If there is many math lab is concerned, there are, I heard that there is a math lab in each of the buildings in Harrison and also in Mount Pleasant. So I don't know the timings, but you can use math labs for the assistance, any kind of assistance you need. So so it is your responsibility to get that help if you need. Or in case of anything, I will be writing down my office hours when you can contact me. And other than office hours, you can also contact me via email. And if you need any extra help or extra timings, if I can make, I will be open for you, and I can help you. So this is the most important part for this course outline, that what are the things we will be covering. Total 10 chapters will be covered from this book. It includes sampling and data. Today we will be discussing on sampling and data, that is chapter 1. Chapter 2 is for descriptive statistics, probability in statistics, and discrete random variables. Almost everything we will be covering in this section. Only chapter 5 and chapter 11 we will not be covered from this book, but the rest of the chapters we will cover almost all of the things. So one more thing I would have be mentioned here, because I know that I told you that there will be 3 tests all over in this semester for you for this course. Test 1 and test 2 has 100 points, and test 3 will be a comprehensive exam. So it means if it has 150 points, I think I should open my Google. Somehow I should open my Moodle shell so that I could show you. I don't know. Okay. Because if you will see on the Moodle, you can see the units. I have divided all the chapters of this books in the units. Let me go on my note. Yeah, this one. I think I would be able to open my. Yeah, this one. Yeah, if you see my Moodle shell, you will see the units. This is the Zoom class, and we can join the class at the timings. The syllabus is provided, and textbooks is also available over there. And all the chapters from this books I have divided into 3 parts, so which I make it in units. The unit 1 will cover chapter 1, chapter 2, and chapter 3. So in first test, it will only cover, the first test will cover only chapter 1, 2, and 3. And unit 2 covers 4 chapters, which is 4, 6, 7, and 8. And that is also, there will be a test in the end of the unit 2, and that test will be only from chapter 4, 6, 7, and 8, and it will be not from the unit 1. And as far as unit 3 is concerned, there will be 3 chapters, 9, 10, and 12. But as the final exam will be comprehensive, that has points 150. So 100 marks will be from unit 3, and 50 marks will be covered from unit 2 and unit 1. I hope it makes sense for you now. So this is what I wanted to let you know. Okay, where is the syllabus? This, okay. So almost according to this pattern, we will cover everything in this semester. So as this is the first week, so we will cover chapter 1 and the syllabus. And there will be an activity for you in the end of each week because this is your first week. So I might be giving you some kind of quiz, but that has no points. Like I can ask you about syllabus, at how many, like what did you understand from the syllabus, like things like that. So because I need to make sure that you are present in the class and you are listening to me. So all the homeworks and tests will be due by Friday at 5 p.m. Or if there is any changes, I will let you know, because I do reserve the right according to the circumstances. If there is some changes happen, I will let you know accordingly. Okay, so let's start from chapter 1 today. Okay. Okay, this chapter 1 is almost all about the introduction, all about the definitions and keywords. It gives you all the background knowledge of the statistics. So it most of the things, and mostly and mainly it is concerned about all the definitions and keywords in it. So we will go through one by one each of these things. So chapter 1 is sampling and data. Okay, so why it is important for us to study statistics? Why do we need statistics? Why it is important for us that that statistics has some applications in real world, and we do see it practically and we use it. Where do we use it? So it's very important to know that why you are studying this subject. So statistics is basically a study of data, and data is everywhere. You are living in the world where data is everywhere. For instance, I am here in this class and I need to know how many students are enrolled in my course. For instance, there are 8 students, 9 students, how many females are there, how many males are there, what are the age groups, what is their ethnicity, what are their nationalities. So this is all kind of data we are having. So the most favorite example that you will never forget ever in your life, which is COVID-19. This is pandemic season. So we know that that COVID-19 has happened, unfortunately, but most of the people have been affected with the coronavirus. So do you have time to go each and every house? Let's say we're talking about the entire USA. We're talking about entire America. So do we have time to go in each house and check, do you have coronavirus? Do you have coronavirus? Do you have coronavirus? No, you don't have time. You don't have time to go in each town. You don't have time to go to each state. You don't have time to go to each and every house in each state. So this is why we need statistics. How we can analyze things, how we can see things that, okay, if this case has happened, how I can control this situation. This pandemic happened, how we can overcome it. And if I want to overcome this situation, what are the precautionary measures we needed? What are the experiments we needed? What are the mathematical tools on it? So statistics is there. We need statistics to solve these problems. We have to get this information. For instance, as I told you, this is a study of data. So this is all the data that has been collected in each hospitals, and it is going to the healthcare system, and then it goes to the CDC, and then sometimes people get this information from CDC, they pay for that to get that data that how many people have been affected with the COVID-19 and what are their age groups, how many, what are their nationalities, what is the race and what community they belong to. So because as we heard that most of the old people have been suffered the most, how do we come to know that more old people have been suffered the most and they are in more danger zone for this COVID-19. So this information we have to collect due to statistics, but by using statistics. And we know how by using mathematical tools or by using statistical methods, we can overcome these situations. Then we can, what we do, we will not take the entire USA, we make a pieces for it. We take a, let's say one state, we are covering it like Michigan state, or we make it into parts and we take few people from each state. And then from the small group of people, we analyze or we predict something, we make conclusions for the bigger things. So this is why we need statistics. Another the very good example I can give you, the forecasting. The forecasting means, for instance, the dollar is getting high or up in other currencies. So what is the dollar exchange rate in Canadian dollars? So if you go over to the Google, you see things that, okay, in 2020, so 2022, by this time, the forecasting says that it will be high or up, or it will be going down, or what is the forecasting? So there is statistics. Another thing you can see, because this is the world of artificial intelligence, we use robotics, we use Alexa, we use Siri, we ask them, hey Alexa, what's the time? What is the weather? And then it tells you how these things can be made. So these machineries have been trained for this thing by giving them some kind of data. It's a lot of data behind it that has been installed into the machinery, and the machine has been trained for it to understand the things, and they can give you the right outcomes and give you the right answer after it. So there we use statistics. Similarly, if we see the nowadays, I have seen that in Singapore, there is a machine is available that if you, in that machine, if you put any kind of fruit, like if you give them like orange in it, then it will tell you whether it is juicy or not. So those machines, without peeling them, it can tell you whether it is juicy or not. How does it happen? Because that machine, that report has been trained with lot of data behind it, with lot of statistical methods behind it, so they can predict or analyze the right things for you. Similarly, self-driven cars, we are here. We are using Tesla, and in Tesla, there is a self-driven facilities available. How it has happened? This is not a magic. This is all the things has been happened by using statistics. So statistics is a very evolving and dynamic subject. And now the statistics is behind everything. And I think nowadays, everybody needs statisticians to work with their lot of projects and lot of complicated problems. So in any industry, healthcare industry, if you go for business industry, so they have numerous data they want to cover up with, they want to understand the data, because data is everywhere and it is increasing at an explosive rate. And the challenge is how we can make sense out of this overwhelming resources and how we can use it in a meaningful and usable information, you can get out of it. So statistics can help you to do that. This is why we need statistics. So hopefully now you understand that why it's important to study statistics and why you are here in this class. So welcome to statistics. So as I said that statistics is a study of data. So what is data? Data is, whenever we talk about the data in this entire course, it is actually all the observations that we have been collecting through some way, through some charts, or through some samples, through some experiments. So this is a kind of all the observations we are collecting. So data is any observations that have been collected. So if we define statistics in the more generalized form, then statistics is the study of how to collect, organize, analyze, interpret, and draw conclusions from it. So actually, statistics has been divided into 5 parts. The first thing is, the most challenging part is how you can collect the data. And sometimes collecting data is not easy. Sometimes collection of data is very expensive. Nowadays, we have computers everywhere, we have internet, we have globalization, so we can collect data, we can talk people around. But before globalization, before internet, people, if I need some information from California, then people have to go there and they have to do survey by physically going there, and that is very expensive to do the survey by going there, and then you can ask people to see things what has happened. To collect data is very expensive sometimes. So if you have data, so in artificial intelligence, if I tell you that like in robotics or whatever, if you have data in artificial intelligence, then 90% work is done, because collecting data is itself is not that easy. So if you have a data, that means 90% work of in artificial intelligence has been done, and machine learning has been done. And the rest of the works you use just for mathematical, statistical methods and tools to work on it, and then you get the interpretation from it. So the first thing is how to collect the data. The second thing is we have to organize it, because collecting data, if you see this column, this chart, so you can see, let's suppose here, the first column is telling you the time. The second one, these are the variables. So actually, each row is giving you the observation of one entity. For instance, let's say the first row is, I'm talking about the car, and a car is traveling this time. What is the mile per hour speed? What is the speed of this car at this time? So this is like variable. So variable means you are going to assign some, you are checking some features, you are checking some properties of certain object. So that is a variable. You're checking its height, you're checking if it's a person, you are checking its age. So that is also a variable. So sometimes you go through when you collect the data, you see that sometimes we do not have any value in it. For instance, if I go for a survey for in a village or in town to get some knowledge that what are their income or what are their ages, so what the ethnicity they are having. Sometimes I forgot to ask that, okay, what is their age? I forgot. So then I have to write something over there. It is nan. Nan means there is no value in it. So if you have some missing data in it, so you cannot work properly with that data, because you cannot get the right predictions from it. If there is no value in it, you cannot get the better outcome from it. So you have to first solve it. Either you have to estimate that value, or you have to delete the entire row so that it will be overall gone. It is useless for us. So then you can organize the data. So first thing is you collect the data, and then you organize it, and then you summarize it. Summarize it, that means you do some analysis with the data. You make some graphical methods to analyze things. For example, if I want to check that in mid-Michigan, what are the house prices in what years? For instance, x-axis I make for the years, and the y-axis I make for the, what is it called? The house rate. What is the house price? The price for it. So independent variable has always been on the x-axis and dependent variable on y-axis. So because year doesn't depend on the income, year doesn't depend upon the value of the house. So year has to be on the x-axis, and the price value or what is the income, it has to be on the y-axis. So you do some analysis by summarizing that data. You use some graphical methods, then you find some patterns in it. These are the patterns you are like, this is the line chart, this is the pie chart, sometimes this is pie chart, sometimes you use bar charts. So different kind of charts will give you different kind of situations. You can see the data, that what is the pattern in it, either whether it is increasing, whether it is decreasing, whether it is steady, or what is the pattern in it. So this is very important for us. So from there, we do analysis. So the first four things, actually it is collecting, and then summarizing, organizing, and then summarizing or picturing, you can say. The third thing is, and then you analyze it. So this is the first four parts. And the last part is interpretation, because if you see the last picture, in this one, you see that till it's very, it's not in, the good mode, I mean. So these are the years actually on x-axis. So till this line, this is past. So these information I know before the past line, I know that what is the pattern. This is the pattern it shows. So I know that this is increasing way. So due to this analysis, I can see, okay, because this is increasing, so I forecast for the future that if this is increasing, so the rest of the time it also be increasing. So that is my interpretation. That is my conclusion from the data. That is my analysis from the data, right? So hope it makes sense to you now. What is statistics? So statistics is collection of data, and then you organize that data, and then you summarize it, like you picture it, and then you analyze that data, and from that analysis you find the conclusions. So that is actually called interpretation. So statistics is the study of how to collect, organize, picturizing or summarizing, and analyze and interpretation or draw conclusions from the data. So here we talk about the population. If I'm concerned with, let's suppose I want to know in Mid-Michigan College that in the end of each year, what is the final, or each semester, what is the final score, or what is the final grading for each of the students in this Mid-Michigan College. So that means I'm talking about each and every individual in Mid-Michigan College. So that means if you study the entire group or each elements in that group you study, so that means this is called population. You're talking about population. If you study each and every entity of the group, that means you're talking about population. And if you talk about some subset of it, for instance, in Mid-Michigan, I'm not talking about Mid-Michigan, but I'm concerned with those students that are enrolled in probability and statistics. What are their final grades in the end of the semester? So I want to concern with, so I'm getting that information. So that is the sample, because you are sub part of Mid-Michigan. You are enrolled in Mid-Michigan. So this is why this is a sample. So sample means when you study some subset of a population, that is sample. And you also have seen the census. When we talk about census, you have seen that in every 10 years, you get some forum, they ask you what is your age and what is your gender. You need to write that information on it, and you have to send it back to them. So that is called census. We do it every year. So for the entire USA, we're talking about population, how many population in USA. So that is called census. So when census comes, that it means we're talking about population. So so if we are talking about data, because statistics is a study of data, if you're collecting the data, then we, for instance, if you are collecting the data, then it should be in some form, right? It should be in some mathematical measurements, right? Because let's suppose in last example, I told you that I am concerned with the average score or the final score of, or average mean or something like this, that because average score means that you are talking about mathematical measure. This is mathematical measure. You are taking the average of something. So this is mathematical measure. So then you're talking about mathematical measure of the population. That is, it means that is the characteristics of a population. So that is called parameter. When we talk about population, if I say like I'm concerned with what is the average score of each student of Mid-Michigan in the end of summer semester. So that means We're talking about mid-Michigan and we are using the mathematical tool with it. So that is the characteristic of population. So that means this is parameter. And if we talk about the mathematical measure of sample, that means we use statistic. So these are the examples that I have mentioned. So first thing I already discussed, that average score of subpart of mid-Michigan, let's say I'm concerned with average score of 3,000 students in the final exam of mid-Michigan. So that means we're talking about statistic. If we are concerned with average score for all the students in the mid-Michigan, so that means we are talking about parameter. Similarly, there is another example, proportion of 2,000 randomly sampled participants that support the death penalty. So from USA, I'm taking 2,000 people, but I'm choosing those people randomly. So I am finding the proportion of those 2,000 people from the entire USA, that what do they think about, or how of those people who support the death penalty. And the proportion of the entire USA, if I'm talking about that support the death penalty, so that is called parameter. So this is what we call. And here, one thing I would like to mention, that data always has to be random. I want you to note down this thing, that if you choose the data, it always has to be random. Why? I can give you one example for this. For instance, if I want to know during this COVID-19, how many people have been unemployed in Michigan State, let's suppose. So if I want to know that how many people have been unemployed during this pandemic in Michigan State, then I will not check only the health industry. Because in health industry, they need more doctors, more nurses, more people to work on, and people will get employment over there. They will be employed for sure. So it means my selection is biased with that. So if my selection will be biased, if my collection of data is biased, and I know what will be the output of it, then that will not the good. That is not the good sample for you. That is not the good collection of data for you. So it means we need the data always has to be random. So it means if I want to know how many people have been unemployed in Michigan State, so then I will have to go for each and every industry. I will have to check automobile industry. I will have to check agriculture industry. I will have to check entertainment industry. I will have to check transport industry. Each and industry, I have to check that how many people have been unemployed. Then I can get the better prediction or better output that to check that, okay, how many people have been unemployed in it. I can get the better estimation that most of the people have been affected or less people have been affected in Michigan State. I hope it makes sense, right? So when we talk about data types, then it has always types in it. One is qualitative data and one is quantitative data. For example, in this case, qualitative data means non-numeric data. So non-numeric data, sometimes we assign it with the category. For instance, if I'm talking about the gender, say for instance, in my class, how many students are male or female? So this is numerical. This is not numeric data because you are not counting the numbers. You are just finding that is it male or female. So this is called the non-numerical data. So qualitative data means non-numeric, that describes the entity by placing the entity into a category of the group. So it means it is actually category of that group. So it can be the example of for this thing is gender, race, religion, nationality. And there is one more example, or I have a question from you to think on. If I take the zip code, the postcode, then is it a quantitative or qualitative? This is non-numeric or numerical number. What do you think?
I would think it'd be qualitative.
Qualitative. Why?
Because even though it is a number, it's referring to a location, not
Exactly, because it's telling you what's the location it is, but it doesn't associate with any kind of number. For instance, let's say your postcode code, let's suppose 58236, and my one is 58239. Then subtracting these numbers, you cannot get someone else's zip code,
Yeah.
right? So it doesn't make sense. So this is why zip code is a qualitative data. Similarly, there could be some other examples as well that actually assigns with the number, but that is actually not a numerical because mathematical operations doesn't make sense with this kind of data. So quantitative data is that has a numerical values in it. So for example, height, age, weight, or car is moving with different miles per hour, or the temperature, what's the temperature outside or minimum temperature outside, because we can make mathematical measures. I know the temperature is outside, let's suppose 18 degrees centigrade, or tomorrow it was 20 degree, or like I can say 40 degrees centigrade, and I can say that, okay, it's 2 times higher than the previous day, right? So I can make mathematical operations with that. So that makes sense with the numbers, and I can make mathematical operations with it. So that is quantitative data. If I further classify the quantitative data, so it will be of 2 types. One is discrete data and one is continuous data. Discrete data means that are countable, that are finite. For example, if I say how many students I have in my class, right now I can say it's 1. Maybe some students are online, then I can say that, okay, 3 or 4, right? But I cannot say it's 2.5 I have in my class students are, unless someone is absent-minded or it's satanic, right? So it's not, so these are the proper numbers in it. So discrete data means that is countable, or I can say the number of eggs I am going to buy the dozen eggs from it. I cannot say that 12.5 eggs I'm going to get. No. So this is the proper value, proper whole number in it, the integer value we are having, or the entire number these are countable. And the other type is continuous data which has infinite possible numbers. For example, height and temperature. If let's suppose my height is 5.6, or it might be 5.6 or 5.67 in the middle of it, right? So there are infinite numbers between 5.67 or 5.6 only. So 5.6 and 5.7 have infinite numbers, 5.6.0001, 5.6.0002. So these are the continuous, there are infinite many values in it between 2 numbers. So this is a kind of interval you talking about when you talk about continuous value. That means it's an interval and infinite many values exist in it. So these are the examples that like temperature and height. So far we have classified the data types into 2 types, which are the one is qualitative data and another is quantitative data. The other level of measurements for the data is one of the 4 these levels to measure the data, and it shows it is also in the ascending order, that how we can it tells you how you can make sense with the mathematical operations with the certain type of data. Whether it is in order, whether we can use some mathematical operations with that. So the one of the mathematical measurement is nominal data. Nominal level of measurements means when these are the categories that are not in order, because nominal, from the name you can think of it is associated with the name. These are associated with the labels, just like gender, race, ethnicity. So these are the names, or I can say how many presidents of the entire of how many presidents, what are their names from 1995 to or 2021, what are their names of the president so far. So these are the names I'm talking about. So these are all the labels, these that are associated with it. So these are the nominal data. Another one is, and in nominal data, mathematical operations doesn't make sense, because I cannot say that the female is greater than male or male is greater than female. No, it doesn't make sense. So mathematical operations doesn't make sense with the nominal data. The second level of measurement is ordinal data. Ordinal data means when you categorize it into an order, but differences doesn't make sense with it. That means you cannot subtract one value to another. So ordinal comes from order. So these are in order, but you cannot make mathematical operations with it. For example, if you use some kind of app in your mobile, I have, let's suppose I'm using some walking app I'm using. So how many steps I have made. So that kind of app I'm using. In the end of that app, it asked me for the feedback from 1 to 5. So 1 means you are highly disappointed. 2 means you are disappointed. 3 means you are just satisfied. Or 4 means you are good, you are happy. Or 5 means you are strongly happy or strongly recommend this application to others. So it doesn't mean that you can find the difference in it. I cannot say that 2 minus 3, I am dissatisfied with it or I am strongly agreed with it. So these are the rankings has been made, that how much you have been satisfied with that applications that you are using in your mobile phone. So this kind of data is ordinal data. That is some kind of feedbacks or rank, you can say. This is ordinal level of measurements. The third point is interval. Interval, this category can be ordered and differences can make sense into it. So it means it will be in order, but and also differences can also be made in it. But it has no natural zero in it. So what does it mean by natural zero? Natural zero mean here that has no value in it. That is empty. That is no value. For example, if I ask you, what's the temperature outside? You will tell me, okay, it's 18 degrees centigrade, 6 degrees centigrade. It can be 0 degrees centigrade, but 0 degrees centigrade doesn't mean that it has there is no temperature outside. So that has no natural zero in that quantity or in that value, right? So these type of values we associated with interval level of measurements, where we can make it in an order, we can also find the difference, but we cannot find natural zero in it. It cannot be empty, right? So the last level of measurement is ratio. Ratio means that you can, it covers all the things. It has mathematical operation sense with it. You can make it in an order, and the differences also make sense with it. Mathematical operations makes also sense with it. And it also has natural zero as well. For example, if someone has a bank account and I am saying that, okay, last year he has like $20,000 in his bank account, or it might happen this year he has no money. So it means no value in it, empty, right? So it has zero existed in it. Or I can say it is $40,000 in this by the end of this year. So it means double times. The proportion is 2 times higher than the previous year. So that means that kind of data is ratio level of measurements it is. So far we categorize all types of data. First is we defined it qualitative. Quantitative means numerical, non-numerical. Then we further categorize it into 4 level of measurements. If we talk about quantitative data, so that can be of 2 types, discrete and continuous. If you further go down with the classification of the data types, then you can see 4 level of measurements. These are nominal, ordinal, interval, and ratio. And it is in order. Nominal has no mathematical operations with it, and ordinal, interval. So ordinal means that has mathematical operations, doesn't make sense with it, but interval has mathematical operations with it, but has no natural zero. And ratio means it is everything, right? But it is not nominal. Okay. So we have, this is the Excel sheet, which is this is the data set I am having from NHANES, which is National Health and Nutritious Examination Survey that was held by Center of Disease Control. It actually survey about all the health and nutrition of each child and adult in the entire USA. So in this small Excel sheet or in this small data set, we are having IDs. So IDs mean it is associated, again, it is nominal because we are assigning one number to each person. It could be a child, it could be an adult. Or BMI, which is actually the ratio of your weight and height. And the race, it's also there. So 3, 5, 3, 4, 1, 2, 3. So what it is, it has been defined here. One means it is, if it is 1, that means it is Mexican American. If it is 2, it means other Hispanic. If it is 3, this is non-Hispanic. 4, then it is non-Hispanic. Sorry, 3 is non-Hispanic white. 4 is non-Hispanic black. If there is other, then we will assign it 5. And adult is 1 and 0. So if it is 0, that means all the people who have ages less than 18. And 1 means who have ages 18 or greater than 18. So this data set is available on the following website. You have to define that in each column, which one is quantitative or which one is qualitative data. This is what you have. I want you to take a pause, the people who are attending online lecture. I want them to take a pause and think about it. That what is it, which features are qualitative and which features are quantitative? Okay, let's talk about the ID. As we said that it is categorical data, which is qualitative data. What about BMI? These are numbers, or these are just associated numbers to something. It's a numerical values, you can see. But so it means if it is numerical value, if these are the numbers and has numerical value in it, because it's a ratio of weight and height. So if its weight has a number and height also has a number. So these are the numbers, and ratio of those numbers will also give you a number. So it means these are quantitative data. Next, you have to think whether it is quantitative continuous data or quantitative discrete data. If we discussed about discrete means countable or finite. You cannot make points in it. Okay, 2 point, I cannot say 2.5 number of students present in the class. I give you an example, similarly like this. So this discrete means countable and continuous means infinite. So if you see here, these are in points, decimal points. It could be 0.333, 0.30001 also. So these are continuous data, continuous values, quantitative continuous data. So if we talk about race, so though these are 1, 2, 3, and 4, and 5, these are numbers, but these are actually not numbers. These are associated with something which is mentioned here. One means Mexican American. So these are labels. So if these are labels, then this is categorical data. This is qualitative data, right? And if you talk about age, so age is a number. So age is a number. So this means quantitative data. Similarly, adult. Okay, if we come to the adult 1001, so one means 18 or less than 18. Sorry, 0 less than 18 age, and 1 means that 18 or greater than 18. So it means we are associated with the range of the numbers. So this is we are labeling the data with some numbers. So this is actually qualitative data. So here is a question for you. The age of the individual was recorded in enhanced data at the time of the survey that I have shown you previously. What type of variable would age be considered? Hopefully I have answered you. So age is a number. So these are the options for you. One is categorical, nominal, categorical ordinal, quantitative continuous, quantitative discrete. So because first you have seen categorical, quantitative. You can select like this. Okay, age we are talking about. So first you have to check whether it is categorical, whether it is quantitative. So age, we know that this is number. So if it is number, so that means quantitative. So okay, these to be two options, whether it will be quantitative continuous or it will be continuous discrete. So you have to check. But when I go to age, so these are the entire numbers, 22, 14, I cannot say 14.555 something, no. I cannot make it. So these are whole numbers. So these are finite values. So this means this is discrete value. So it means the last option will be correct, quantitative discrete. Similarly, you have a next question. I would ask you to take a pause and think about it, and I will ask you in the end of this lecture. So the question is, the adult indicator variable is coded as 1 if the individual is 18 years of age or older, and 0 if not. So what type of variable would the adult indicator variable be considered? Okay, so I want you to think on it. So let's come to the statistical methods. We have seen that if we collect the data and if we summarize those data, it gives us some kind of useful information from it. And mathematical methods gives us the tools to get the useful and meaningful information out from the data. So these methods have been categorized into 2 types. So if we, if you remember, I have discussed the statistical, the definition of statistics that comes with 5 parts, right? 5 steps in the definition of statistics. What was that? Collection of data, organizing that data, summarizing, picturizing, and then analyzing. So till analyzing or summarizing that part, so the study of the first 4 things comes into descriptive statistics. So that means describe the situation. So if we describe the situation, that means we are summarizing the data in a meaningful way. The second one is inferential statistics. Inferential statistics, we are getting some outcome from the given analysis. So infer results of a sample to a population. So it means from taking a small group or population, we study on that on the sample. And so if we study on sample, it means we have some analysis on it, and we are getting some predictions or better outcomes for the future from it for the entire population. So that is actually inferential statistics. So in this book, the second chapter and the last chapter, we will discuss on descriptive statistics. The rest are the last 4 chapters are on inferential statistics. The rest is probability, right? So these are the methods that we will discuss in this course. When we have to study the data, of course, we have to do some experiments, we have to do some observations, we have to work on that. So first, let's see what is observation. So observation means that you are sitting down and you are checking something. For example, if I'm standing on the highway and I'm checking at this time, the car is moving in front of me, what is its speed? At what speed it is moving, and I'm just writing it down on the paper. This is called observation, right? So that at this time, the car has been moved with this speed in this miles per hour. So this is called observation. So observation means when you sit down and you're doing something, you are just observing that state, but you are not going to change anything. For instance, similarly, if I'm going to the hospital and Sparrow Hospital, I'm asking them how many people have been affected today with the coronavirus. So they are giving me information. Okay, today 1,000 people came to our hospital for the treatment. So they are affected with the COVID-19. So this is just observation. I'm not doing anything with them. I'm not doing anything with the patients. So this is called, so this means measure something, measure specific traits that does not modify the subjects. You are not changing anything into the subjects. But experiments mean that you apply some treatment on them. And what is the treatment? How we can overcome it? We have to use some precautionary measures. We have to get vaccinations. We have to use masks. We have to use social distancing. And then we can see how it can affect now the situation, that will it get better or will it get worse, or what will happen next. So this is called experiments. When you, so in statistics, when you apply some statistical methods on it, on the subject, and you check the results after it, that is called experiments. So observation, you just collect it, you just writing it down on the paper, and experiments mean when you apply some statistical operations on that. So one thing we already discussed about random. The data always has to be a random. to get the better estimation. So what does random means? That each population or each member of a population has an equal chance of being selected. So this means if I have a student, if I have a class of 12 students, so, and I want to take a sample size of 4 students from you, then it doesn't mean that I have to be fixed on one point. Okay, I am selecting you, and you. Like on, if I'm looking at here and I'm selecting from this place, no, I have to, what I will do, I will assign some numbers to all of you, like 1 to 12, if there are 12 students, and I will mix you together, shuffle you up, and then I will select the 4 cards from it, like 4 students from them, right? So this is called random, that each entity has an equal chance for being selected. Is that all right? So then comes to simple random sample. Simple random sample means that each group of size n has an equal chance of being selected. So simple random samples means you are dividing it into groups, or you are taking, if I have, let's suppose the Michigan University, Mid-Michigan has 1,000 students, and I am going to make it into sizes. Like I take a groups like 100 students, then I have to make 10 groups for each. So like 100 size of groups for all of these students. And if I have to select from like 2 groups from them or 2 sample space from them, then it could be anyone. It could be, might be one from Harrison campus, one from Mount Pleasant campus. So it has to be random, or it could be from one section. But if I will be specifically from one section, then it means I'm biased to my selection. So simple random sample means you are divided into groups and each group has equal chance to be selected. So that is called simple random sample. Okay, if we talk about sampling, so there are different techniques to do samplings with it. So these are the 4 sampling techniques that we often use. So the first one is convenience sample. Convenience sample means from the name, we can see that it is easy to select. That is easy for you to select. For instance, if I am going to choose 2 students from this class, let's say we have 10 students, then whatever is easy for me, I can get it, right? Because 2 students are fine, okay, I'm selecting them. Okay, come and do this assignment, do this project, right? So that is easily available. For instance, if I am going for, let's suppose if I want to see, let's say, what people think of the presidential election, who has to be selected for this year, right? So what is the convenience sample for me? The convenience sample for me is not that I would go for someone whom I don't know, right? The convenience sample for me, I will go to my friends, I will go to my family, and I will ask them, what is your opinion for the presidential election? Who has to be selected? So this is the convenience sample that is easy for you to understand. But this kind of selection sometimes is not good. Why it is? Because for instance, like presidential elections, if I say some TV channels are biased for one person, they know that who has to be selected. I cannot select only people from those TV channels to find out that who has to be selected for this year, right? So this is why it is not a good option for us, because sometimes it is biased and it is not a good option for us to go for. So what is systematic sample? The next is systematic sample. Systematic means from the name you can see that it has some order in it. System means order. You are taking some order in it. So systematic sample means if you put a population in some order and pick every case. For example, I want to check that people go to the bank and they want to withdraw the money from not by the ATM machine, but they want to get the service from the help desk over there who are available at the cashier. Okay. And there is a line over there. There is a huge line, maybe 20 people are there. And let's suppose we take this example that is in front of me. They are in line 1 to 12, right? I want to select the systematic sample of 4 people from them. So what I will do, these are in line. I will start from any number. It could be 1, it could be 2, it could be 3, it could be 4 also, right? It could be 5 also. You can start from any number. So, but the next number, you will choose every kth number. So every kth number, let's say I am going to start here from 2 and k, I select 3. My k is 3. So the beginning I choose randomly. The next person I will go for the third person. I will count down 1, 2, 3. So this person is 5. I will add it into it. After that, I will again count. What is kth number? Third number. Next third number will be whom? 6, 1, 2, and 3. So 8 will be counted in it. And then again, I will start 9, 10, 11 will be counted, and the rest is empty, right? So I have now 4 people of selection. So this is called systematic sample, that you start from any number and you select after that any kth number after it. And right after any again kth number, again kth number, again kth number. Do you know what I mean? So this is called systematic samples. The next is stratified sample. Stratified sample means it comes from strata. So strata means you categorize the data with some properties in it. So what is stratified data? If you have a people, here we have 12 people in it, in this group, and I want to break this population because this is my population. The big set is set of 12 numbers. So I want to get the sample space from this population. So I break this population into subgroups based on these characteristics. Maybe I divide these people into their age and also their income level. Age and income, I'm dividing these people into 3 categories. So these people are in one category who are of same age, who might be under 18, or I'm checking their income. What is their income? Maybe they are working somewhere, right? So they have some income. And next I'm going to, let's say 18 to 40 years old. And this is the 6 people are there and their income is something, and I'm going to check their income. So these are divided by ages. So the next is above 40, all the people, and these are the 3 people are there. So I divide my population space into categories. So these categories actually called strata. And now you have to take the sample space of 4 people from each of these stratum. So how would you do that? The proportion has to be similar. I know that these are 3 people out of 12. So this is 1/4 of this population space, because 3/12 is 1/4. So 1/4 of the population. These are 6 people. So this be half of the population, 1/2 of the population space. And again, this is 3. So this is 1/4 of the population. If I want to choose 4 people, so it has to be equal proportion. So 1 I will choose from first stratum, second from this stratum, 1 single person, and 2 people from there, because this is the largest group, half proportion of the population. So I'm taking 2 of these. This is why I'm taking 2. It could be not specifically 2 and 8. It could be 4, 6, because it is random selection. 4, 7. It could be 4, 11, and 2 and 8. And the next, it might be, because we are choosing 1 from the first 3. So it could be 1, it could be 10, it could be 12. Anyone you can choose. So it has to be random. And similarly from here, you can choose randomly. So this is how we stratify the data by stratified sample means you are categorizing it. You are dividing the population into category. And then you take randomly from each of these strata, you choose 1 people or how many people, according to the proportion you will go for, and then you will select the items from that. This is called stratified sample. This is the last one, which is cluster sampling. So cluster sampling means I have a group of people, I shuffle them up. I do not categorize it. I shuffle them up I am not concerned with their age, I'm not concerned with their income, but I shuffle them up. And these 12 peoples, I want to make the six category in it. 6 clusters I want to make, and it could be anyone. 1, 2 is in this group, and 3, 4 in this group, 5, 6 in this group, 6, 7 in this group, 9 in this group, and 11, 8 in this group. So these are the clusters. Then what you will do, you will choose any random clusters from them to choose a sample. This is why you choose 2 samples from them. So it might be this one, 5, 6, or it could be the first cluster as well, first and last. It could be this one and this one cluster as well, if you want to make a sample space of 4 people. And for instance, if you want to categorize this cluster into, from this cluster, if you want to choose the 2 samples, then you can again randomly choose 1 sample from here and one person from here. Again, you can stratify it with your sample space of 2 people. So this is called cluster sampling. So I want you to think on these things. This is for your class exercise to think on. So far, again, we can summarize what we have discussed today. So in today's lecture, first of all, we have seen where we use statistics, and I hopefully gave you a lot of examples that how we can see statistics around us, so how we can use it actually. The next I defined, because it is study of data. So data means observations, and statistics is actually the process of collecting data, organizing it, and then you can summarize those data and analyze it, and then you can find the conclusion for the future for the entire population. And when we talk about the big group, that means population. And when we talk about the subset of the population, we are studying subset of population, that means we are taking the sample space. This is the difference between sample and population. And if we talk about any mathematical measures, or if you're interested to find any mathematical measure or category of a population, that means we are talking about parameter. If we are talking about mathematical measure or category of any sample, so that means we are talking about statistic. So statistic means any mathematical measure of sample space. Again, we look for the data types, because if we are collecting the data, you have to divide it into 2 categories. It could be numeric, it could be non-numeric. So non-numeric data could be categorical data. You find categories in it like gender, race, nationality. These are all the categories. And the next we discussed categorical data can also be qualitative data also. And the quantitative data means numerical data, and it could be numbers. And the quantitative data, further we go down to its classification, that was discrete and continuous. Discrete means entire number, and the continuous mean it has infinite numbers of in it. It is uncountable, or it is infinite. Further, we go to the level of measurements. It was nominal, ordinal, interval, and ratio, and it is in the order as well. So nominal means we use for labels again. Mathematical tools doesn't make sense for it. You cannot find the differences or addition with it. And the rest is, then we discussed about the ordinal. It could be in order, and mathematical, but it could be in order, but you cannot find the differences in it. Just like an app, you are giving the feedback from 1 to 5. So that doesn't make you can find the difference between it. It can be mathematical measures doesn't make sense with it, but ordinal means you can make an order. You are highly angry, or you are highly disagree, you're highly disappointed, or you are satisfied with it, with that app. So this is called ordinal data. The next is, we come to the interval. So interval means you can make differences. That is in order also. You can find the difference, but it has no, don't forget that it has no natural zero in it. So no natural zero means it has no empty number in it, just like temperature, just like height, just like age. So it cannot be zero. It has to have some number in it. And the last one was the ratio. Ratio has everything except nominal. It was in order, differences make sense, or mathematical operations make sense, and also it has zero. It could be an empty as well, just like a bank account, right? The money in it. Next, we discussed the experiments and observations. What are these? If we have to do some experiments, how we can sample those things. And if we have to find those samplings, what are the categories? What are the most often categories we use? So those categories are what number one is convenience sample. The second is, what was that? The stratified and systematic. The second one was systematic, and it could be in any order. You can, it doesn't have to be necessary, it has to be systematic, but you need to know what are these. Convenience sample, that you can take it easily. Systematic comes with system, order, and I gave you an example that it has to, you select from after every kth number, right? Kth is any, the number in it, and you can find another next, another kth, another kth. You need to choose how many sample space you are having. What is the size of your sample space? It could be 3, it could be 2, it could be 5. So how many people you need in the sample space? So, and other is stratified sample. Stratified samples, that comes from strata. That means we are categorizing the group into classes. So we categorize it with different properties, and then we find the samples from those strata in each of those. So the last one was clustering. Clustering has not to be biased. It is not stratum. It is not strata. You cannot categorize it, but you make randomly some clusters with them, and then you randomly choose the clusters, and you need to choose that what is your sample space you need, and then you further go down to your randomly select further and further till you get the sample space, your own sample space that you need. So this is all we have discussed today, and this is the class exercise. I want you to think on it, or we can go one by one. So as we discussed, parameter and statistic. So parameter means the category we are checking the property of population, that is or mathematical measure of a population, that is parameter, or if it is any category of sample, that is statistics. So you need to identify from first two, which are these. Let's suppose first one, a researcher wants to estimate the average height of a woman aged 20 years or older. The next it says from a simple random sample. Simple random sample, I told you that we give them in certain sizes of n. We fix the groups, we make some random groups in that, and then you further select. So a simple random sample, so this is the size n, which is 45 women. So they choose one simple random sample of 45 women, so from the entire USA. So the researcher obtains a sample mean height of 63.9 ages. So what could be the parameter and what is the statistic? You need to think on it. So average height, if we talk about the average height of a woman of 20 years or older from the entire USA, the average height is the mathematical measure. So it means we are talking about the statistical method or statistical tool we are using, which is average height. But for from entire USA, we are choosing all the women of ages 20 years or older. So this statement says the parameter, right? Hopefully it makes sense. From a simple random sample of 45 women, and now we squash it down to a sample that is of size 45 women, and now we are checking the height, and then we check the height is 3.9 inches of those 45 women. So this things, the simple this height, because mean height, it's a sample mean height, we have to find out where is the mathematical measure. The first one has average height, and average height is another word which is mean. Average, mean is the same thing. So mean height, again, this is a mathematical measure. So this statement, because you are choosing 45 women, the second statement give you the statistics. So this comes into statistics. Second, I want you to work on So the next question is indicate which level of measurement is being used in the given scenario. Is it ordinal, nominal, interval, or ratio? So these are the statements are given there, and you have to find out whether these statements are come into ordinal, nominal, interval, or ratio. The teacher of a class of third graders record the height of each statement. You have to think on what it is. Let me see if I have to check whether we have to take. I will give you a pause for this video so that you could think on these statements, because I defined everything hopefully. Okay. So the first one is the teacher of a class of third graders record the height of each student. So what kind of data it is? Is it ordinal, nominal, interval? Because it says the height of each student. So what is the measurement we are going to take? Height of each student. So height comes in nominal, ordinal, or interval. So first start from, let's say, nominal. Height is not nominal because it has not a name. Height has some number in it. So it's not nominal. Is it ordinal? Ordinal means it has to be in order, but what? It has to be in order, but mathematical operations doesn't make sense. But height is a number, and you can count it, that you can subtract it, you can add it, you can check whether it's double the height. He is 2 inches taller than me, or he is 3 inches shorter than me in height. So this is not ordinal. What do you think? So it's not ordinal. So is it an interval? But interval has one thing, that it has no natural zero in it. But we have seen differences you can take interval. You can also keep it in an order. You can find the difference. Or it has no natural zero in it. Though it has no natural zero in it. So, but what do you think about ratio? Because ratio means you can say that this person is twice as mine, or it's not, it's shorter than mine. So I would say it is ratio, because I can say this is 2 times more taller than me. This is 2 times smaller than me. And you can also find the mathematical differences in it. So this is the ratio type of. Similarly, you can think about the next one, which is a teacher of the class of a third grade is record the letter grade of mathematics for each student. So letter grades are associated to what? Letter grades are, if we see our course outline, then it has some letter grades also. We have A, B, C, and E, and F also. So it means A has excellent performance, B is a little bit down, C is then more down, and then, less than percentage is getting low and low and low. So it means we are associating some letters to some numbers, to some entity, right? So in this case, I would think, what do you think? Would it be ordinal, nominal, interval, or ratio? It's not nominal, because this is not just labels. We can order it. Grade could be better, grade could be worst. So ordinal we use for better and worst, and we associate the particular numbers to that also, right? So in that case, I think it is ordinal, right? But it's not interval or ratio, because you cannot take the differences with it. You cannot find the differences are meaningless in grades. I cannot say A minus B, okay, this is the grade you can have. No. So this is not possible. Similarly, I want you to think on the other questions. and then we can discuss is later in the end. So let's think over it. The last three one, which one is these? What do you think? Is it nominal, ordinal, or the rest? I want you to work on. So in the first question, what is the measurement in it? What he is finding? A meteorologist compiled a list of temperatures in degrees Celsius for the month of May. And I think we have already discussed about temperature. So temperature is like, it could be 18, it could be 0 as well, but 0 doesn't mean that has natural 0 in it. So that means we are discussing about what was that? Is it ordinal, nominal, or interval? Interval it is, because interval has no natural 0 in it. This is why, that because temperature, the measurement is temperature, this is why we can say this is interval. The next one, let's think on it. A film critic lists the top 50 greatest movies of all time. The top 50 movies, for sure, all are not on top. All cannot be the first movie or the top one movie. No, if we go for the Oscar awards, everyone not has to be the one for top one movie in that. So it has to be in some order, right? So if we find those things, if we categorize from A to B and C and then D, or 1, 2, 3, we can say this. So it could be ordinal, nominal, interval, or ratio. Sorry?
Ordinal, right?
Ordinal, yes, because it is in some order, but you cannot find the differences in it. You cannot say the fourth movie minus first movie could be some movie. No, you cannot do that. So this is why it is ordinal. The last one is a car magazine lists the most expensive cars for 2017. So it has a list of entries, car magazine, which that he listed down the most expensive cars for 2017. It can happen, let's suppose we say one car is $25,000. If I go for the price, it might be $50,000 in those cars, the top rated cars, the one we have. So it means it is twice expensive than the other car. So if you can compare them with some, again, it's a ratio. So obviously we are talking about ratio. Okay, it's the end of the class. So we can start again in the next class. Hopefully I will give you some worksheets to practice on, and I will upload it on Moodle, and I also have to update my office hours for you and my location. So hopefully it will be available in Moodle. Okay, thank you very much for today's lecture.